In this video and the upcoming videos, we are going to talk about the number line and integers. So a number line, I know you guys have all seen a number line before, but it is important to realize the order of our number system. So we have all positive numbers when we have a typical number line. All of our positive numbers are to the right, right? And all their opposites, all the negative numbers, are to the left. Negative numbers to the left. 0 here, the number 0 is just neutral, right? It's neither positive nor negative, okay, just neutral. One thing to point out with the number line, just recall that the arrows here at the end of each side of the number line, it literally goes forever, right? So a number line is continuous. So on the GED test, it's surely not going to have you just plot a plain old number. But a number line is really helpful when we're comparing numbers, especially when we have positives and negatives going on. So if we look below here, it says plot the below points on the number line above. So a half, if I were to point 1/2, plot 1/2 on the number line, a half lives exactly between 0 and 1. So just a little bit of a review. If you remember, the numerator of a fraction is how many parts you have, and the denominator is how many make a whole. So if we look here between 1 and 2, and if I were to split that into 2 equal pieces, I now have 1 of the 2 full pieces there. So it's as exactly between, right? If the fraction weren't as common as a half, we could figure that out. This will likely be a challenge for me to plot these exactly where I want them to. Maybe I'll use my... So there, we'll say that, and then that is point A. So next we want to plot the number -3/4. So -3/4 is between 0 and -1. And again, if we were to split this into 4 equal pieces, 1, 2, 3, 4, I want to go 3 over. So 1, 2, 3 would be closer to the -1. -5 is a nice sign number. That's a whole number, so we can just find -5 and plot it. Let's see. Next, we have 4 1/4. So 4 is our whole number, so we go over 4 all the way over. 1, 2, 3, 4. And then 1/4 is just a little bit over, right? If we were to split between 4 and 5 into 4 equal pieces, it would be 1 of those 4. So 4 1/4 would be right about here. Next, we have -3 1/5. So negative, we're going to go to the left. So 1, 2, 3. And then -3 1/5 is as if there's 5 equal sections here, and I'm just going over one of those. So E would be somewhere in that area. 1 1/100th. So if we think about 1 100th, is that a really, really big number or a really small number, right? So 100th, that 1 represents 1 is how many we have, 100 is how many make a whole. 100th is as if there's 100 equal pieces in here. So like so tiny we can't even see it, and we're just 1 over. So it's literally like just on the other side of that 0, right? And that would be letter F. Next, I have -2.2. So just a little bit review with decimals here. This -2.2, another way to read that is -2 2/10, because this 2 is in the 10th spot. So we have -2 2/10, which is really the same as -2 1/5 if we were to reduce that. So -2 1/5. I'm going -2 over. If I split this into 5 equal pieces, it's just 1 over. So it's just on the other side of the -2, and that's for point G. And our last number to plot here, we have 0.99. So review again for place value. This 9's in our 10th spot. This is in our hundredths. So this is the same as 99 hundredths. So if I look between 0 and 1, it's as if I have 100 equal spots here. Right? Think of it like I have 100 equals to make a whole, and I have 99 of them, so I'm almost 1. 99 hundredths is super close to 1, as in it would round to 1 if you're rounding to the nearest whole number. And that is letter H. So plotting one number by one number isn't so bad, right? But also just visually here, this shows these numbers in order now from least to greatest. So -5 is smaller than -3 1/5, which is smaller than -2 2/10, which is smaller than, I forget what this one was, F was 1/100th, and so on. So placing them in on a number line is super helpful visual of ordering numbers from smallest to greatest, or greatest to largest. It shows you in order, right? When we're comparing numbers, again, while that number line is helpful, you'll also see inequality symbols. So the less than symbol points to the left. It also looks like an L if you want to view it that way. Greater than is the other way, right? It points to the right. And then less than or equal to is really just a symbol including, it's a symbol that includes two symbols. So it's less than or equal to. So we can kind of see here we have this less than symbol, and then we also have the equal symbol, right? It just kind of combines the two. Same for greater than or equal, so we have greater than or equal to. Okay? So really for the purpose of this below activity, we're really just going to use the less than or greater than. Or another one we really should mention, even though I know we all know it, we shouldn't forget it just about the equal symbol, just exactly equal. Right? So if you want to extend your table there, feel free to do so. So when we're comparing integers, I know you guys have seen these numbers before. We see integers every day in real life as far as ins and outs. Could be your bank account, it could be temperature, it could be for football gains and losses, could be weight, how much weight you gain, how much weight you lose. It really is all over the world. Numbers are, and especially integers. So while I know you have a good grip on what integers are, I will say that this is a common error students make mistakes on when they are comparing integers, whether that be test anxiety or you're just looking through the question too quickly. But this first example here, 3 and -5, well, if I looked at those on a number line, 3 is over here, -5 is over here. So just by location, because the 3 is more to the right, it's bigger than -5, right? So 3 is greater than -5. So really with these examples we're going to work through, you can think money and ask yourself, which would you rather have, right? Would you rather owe someone $7 or have $7? You'd rather have $7, so it's the bigger number. So a way to remember these inequality symbols is it eats the bigger number. So -8 and -2, I'd rather only be 2 down than 8 down if we're talking money, right? So the 2 is bigger, so think of it like this symbol eats that -2, right? Another way to look at it, all of these examples, is it points to the smaller. So however you need to wrap your head around that, make sure you just have a good understanding of that. Another thing, when we read words, we read left to right. No different with math. So if we look at this next example of -56 and -58, -56 is greater than -58. So when I read this left to right, that correct symbol has to go in there. -56 is greater than -58. Or -354 is less than -345. -10 is less than 0. It's more to the left, right? If the numbers are exactly the same, -1 equals -1, right? I guess technically here, you could also put less than or equal to, because it's that condition of or equal to, or greater than or equal to. So really all three of these symbols work here, but this equals is definitely the best one to use. 14 is greater than -15. 43 is greater than 34. So for example, here on that one, I know you all know that. I know you know 43 is bigger than 34, but our eyes play tricks on us sometimes too. And assessments do that also, right? They use numbers that have the same digits, the same number in different digit place values. So just take it slow and make sure you're getting that question right. No matter what the numbers are, if they're a positive and a negative, it doesn't matter the size of them, the positive will always be bigger than the negative.